everyone. In this lesson, we're going to be talking about one-step equations, but with rational numbers. So we've done one-step equations before, but we kept them strictly to integers, but now we're just going to add in some rational numbers. Nothing really different in terms of the steps that we need to follow. So we're still going to follow the order of operations in reverse. We're going to get rid of addition and subtraction first. So let's look at the example x plus 5 halves equals negative 3 halves. Well, because we have addition here, combining 5 halves to the x, we're going to subtract 5 halves from both sides. Great. Now we also know how to add and subtract rational numbers. So we can take, this is negative 3 halves minus 5 halves is negative 8 halves. Well, don't just leave it as negative 8 halves. We can make that x equals negative 4. As simple as that. Here is another example. We have x minus 2/3 equals negative 4. Well, here we would like to add 2/3 to both sides. Now, some people might jump ahead and do this in their head, but if you need to take a second, you could turn this into negative 3 3/3. You could kind of borrow there. Or you could even turn this into negative 12/3. Either way would allow you to better combine that 2/3 with it. So over here we have x, and we're going to be equal to negative 3 1/3. Terrific. We've done an example like that. Here we have mixed numbers, which I don't really like in equations, but just in case you see these come up. We want to subtract 4.5 from both sides. You might go ahead and subtract 4.5, but then over here you might also notice that we have a different denominator. So we're going to have to do a couple of things. I'm going to change this negative 9 1/3 into negative 9 2/6, and I'm going to subtract from it 4 3/6, because 4 3/6 is the same as negative 4.5. Okay, so we have x here equals, so we can combine our sixths, and we have 5/6. They're both negative, so it's important to note that they were both negative here, so that's why we're combining them. And then 9 and 4 is negative 13 here. So that would be our final answer. Let's go ahead and look at some examples where we have multiplication or division. So here we have the fraction 9 halves times x. So some of you might think, let's go ahead and divide because we've got multiplication here. And in theory that does work, but when we're dividing by fractions, we end up by multiplying by the reciprocal. So we're going to jump ahead right away. When you see multiplication here, we're right away going to multiply by the reciprocal. Why is this going to help? 2 will cancel with 2 and 9 will cancel with 9, so all we'll be left with is x. So we're going to go ahead and multiply by 2 9ths on the other side. I'm going to make 18 into a fraction as 18 over 1. And look, we can do some canceling before we multiply. 9 goes into 9 once, 9 goes into 18 2 times. So after all that, x is simply equal to 4. The 2 times the 2 in the numerator. Terrific. All right, here we have a negative fraction multiplied by x. So when you have a negative fraction multiplied by x, you want to still multiply by the reciprocal, and the reciprocal is going to stay negative. So I'm going to multiply by negative 4/3 and do that on both sides. It'll cancel over here. Even the signs will cancel. So we're left with positive x. Over here, it almost looks like things would cancel, but unfortunately, they don't. We want the 3 and the 9 to cancel, so don't get trapped into thinking 9 and 3 are going to cancel right there. They're not, because they're both in the denominator. So we have 27 down on the bottom, and we have 64 up top, and the whole thing is negative. Great. Well, what happens when we have division? So I'm going to show a couple of ways that you might go about this. The first way will probably be the way you'll stick with. So we are dividing by negative 3/8. So we're going to go ahead and multiply by negative 3/8 on both sides. Dividing and multiplying will cancel all of this. And when we multiply this side by negative 3/8, we'll get 3 times 3 is 27, and it's going to be positive now. And 8 times 20 is 160. So x equals 27 over 160. The other way you might like to approach this, and I'm going to clean this up here for a second, is if you liked to think about getting rid of that complex fraction first, as we did in our previous lesson. So we could rewrite this as x times, we're going to make that the reciprocal, negative 8/3 equals negative 9/20. Well, now, because we have negative 8/3, we still want to multiply by the reciprocal, which would be negative 3/8. And we're going to multiply by negative 3/8. So in either sense, you're going to be multiplying by negative 3/8. We get x, and then we get 27/160. Terrific. The last thing that you might be faced with is decimals. And if you get decimals, you're more than welcome to go ahead and just use your rules for decimals. So we could go ahead and divide by 0.75 here and divide by 0.75 here. For me, I'm going to have to go ahead and set up my division here. I'm going to go dividing by 0.75. I want to divide 18. Now our divisor we can't leave as a decimal, so we have to make that 75, but we have to make this 1,800. And 75 will go into 180 twice. That gives us 150, leaving us with 300. And 75 will go into 300 4 times. So we know that x here is equal to 24. That's one approach. Another approach that you might do is, especially if you see a decimal that converts to a fraction nicely, is you might choose to make that 3/4 x equals 18. For me, this is the easier way because then I can go ahead and multiply by 4/3. These cancel. X equals, this is 18 over 1. 3 goes into 3 once. 3 goes into 18 6 times. 6 times 4 is 24. I like that better than doing decimal long division. So that's how you solve one-step equations with addition with rational numbers. Thanks for watching, and talk to you next time.